We have to find out the ratio of the diameter d1 and d2. We know for a circular orifice, the discharge Q is equal to CD into A into root 2Z H. H is head causing flow, and area is equal to pi by 4 d square. Here it is of two diameters d1 and d2. So from the problem we know that the discharge through the orifices are same. Q1 is equal to Q2. That implies CD 1 into A1 into root 2Z H1 is equal to CD2 A2 root 2Z H2. CD1 and CD2 are same. Pi by 4 D1 square root 2Z 0.25, that is equal to pi by 4 d2 square into root 2z into 1. d1 by d2 whole square is equal to root 2z by root 2z into 0.25. Root 2z, this is 1 by 4, this is equal to 2. d1 by d2 is equal to root 2. Therefore, d1 by d2 is equal to root 2 is to 1. The ratio of diameter d1 and d2 is root 2 is to 1. So option D is correct. In this problem, we have to find out the silt factor. We know the relationship in Lacey's theorem in between discharge, longitudinal slope and silt factor. That is, slope is equal to silt factor power 5 by 3 divided by 3340 into q power 1 by 6. Q is discharge. We have to find out F, that is silt factor, is equal to, yes, slope is 15 into 10 to the power of minus 4. We can take like this, and 3340 into discharge is 200 cubic meters per second 1 by 6, that is equal to 12.11. Therefore, F is equal to 12.11 power 3 by 5, that is 4.46. Therefore, answer is B. This problem is saying that the line originally 100 mm was measured to be 85 mm. That means it is reduced from 100 mm to 85 mm. The initial or original scale of the plan was 1 is to 500. It was given. We have to find out the revised scale, that is for 85 mm. 100 we will convert into 1 is to 500. We have to find out x, that is 1 by 500 into 100. Now 85 and revise the scale 1 by y. So y is equal to 500 into 100 by 85, that is equal to 588.23. Therefore, option A is correct. We have to find out the correct distance between the ship and the lighthouse by considering the combined correction for curvature and refraction. The lighthouse of 100-meter height is just visible above the horizon from the ship, 100 meters. We know the height is equal to 0.066142 into horizontal distance or correct distance between the ship and the lighthouse. We know the value of height 100 meters, that is equal to 0.066142 d square. D is equal to 38.883 kilometers, that is equal to 388.3 meters. Therefore, option C is correct. This is the problem related to horizontal curves. The horizontal curve of radius 500 meters is given, and the super elevation E 0.06 is given. the coefficient of lateral friction has to be calculated, and the vehicle is moving at a speed of 80 kmph. We know the relationship between super elevation and coefficient of lateral friction and velocity. E plus F is equal to V square by 127 R. E is given 0.06, F has to be found out, and V is 80 kmph, 127 into 500, that is equal to zero point 0.1. F is equal to 0.04. Here 0.03 is given, and other things are 0.13, 0.3, 0.4. It is very near to 0.03. So option A is correct. If we see into the problem, what we need to find out is the curve length. And the most important thing that was given it as the curve length is less than stopping side distance. Curve length we can indicate it as L and stopping side distance SSD. It is for a vertical curve and it was given two gradients, +4 and -3. +4 and -3. So the relative gradient or the effective gradient, we can say it as N, is going to be 4 minus of -3, that is equal to 7%, that is equal to 0.07. And from this condition we know the relationship for the length of curve. Length of the curve is equal to 2s minus 4.4 by n, where s is stopping side distance that was given in the problem, 150 meters. That is equal to 2 into 150 meters minus 4.4 by 0.07. That is equal to 0.03 is equal to 237.143 meters. That implies option D is correct. It is a direct question. The maximum weld size of if thickness of thicker plate is in between 6 to 12 mm is 4 mm. Option B is correct. Here we have to choose one option which relates seaway thickness. Seaway thickness is nothing but because of excessive seaways that was applied onto the land. So it is going to obstructing the aeration and leading to the septic condition of that particular land. So option D is correct.